graphing quadratic functions, and we're looking at this form here, ax squared plus bx plus c equals y. This should look very familiar to you. We worked with this a lot in the previous chapter when we were solving equations by factoring. So we did a lot of factoring, and this is an equation that we saw quite a lot, this trinomial, this quadratic trinomial here. So what we're going to look at to start off with is we're going to look at what the graphs of these quadratics look like, some different pieces of a graph that we can kind of pull out and that can tell us certain things about the data in that graph. So we're going to start to look at these graphs simply by making a table of values. If you have given an equation and you're told to graph, well, how do I graph that? If you're not really sure, you can always start with a table. That's always a good backup plan. So we're going to start with a table just to see what this graph looks like. So I'm going to give myself a table. I'm going to pick some x values. I like to pick some negatives, a 0, and some positives just to see what happens around the y-axis. And I'm going to plug those values into my equation. So you'll notice this is a lot of work because it's got exponents in it and it's got a lot of operations going on here. So I'm going to start by substituting. So I've got 3 times, I'm going to plug my negative 3 in there, squared, plus 6 times negative 3 minus 4. Please notice as we go through working with these quadratics, that order of operations says I have to do the exponents first. So I'm going to do the negative 3 squared first. That gives me 9. After this, then I can multiply by my coefficient here. So I have 3 times 9 plus, and this gives me negative 18 minus 4. 3 times 9 gives me 27. Negative 18 minus 4 gives me negative 22. I end up with 5, so I'm going to plug my 5 back into my table. I'm going to plug each of these other x values into my equation to come up with my y values. I'm assuming you can figure that out. As you really get into the pattern, you can start to skip a few steps, do a little bit more mental math. That's totally fine. But I do ask that at least the first 2, you do it out the long way so you really make sure you see the pattern because it's easy to make a mistake, especially with this ax squared piece. So once I have my table, I'm going to start to graph those points on my coordinate plane. So I have negative 3, 5, which is up here. I have negative 2, negative 4. I have negative 1, negative 7. And then I have 0, negative 4. It starts to come back up again. I have 1, 5. And then I have 2, 20, which isn't on the coordinate plane that I've drawn, so I can't really fit it. But I do notice that this gets really big really fast. And this is kind of, because we have an exponent in here, things start to get really big or really small really fast. So this shape that we have here is called a parabola. P-A-R-A-B-O-L-A. It's called a parabola. So this is a parabola. It is a curve on the bottom here. It's not a sharp V, so we're not making a V here. There's very much a curve. This just happens to be a very skinny curve to it, so it looks kind of V-like. But there's a curve to the bottom of that parabola. And a parabola, which is the shape that we get when we're looking at a quadratic, has a few certain characteristics about it that I want to point out. So first of all, we'll talk about the fact that it is symmetrical. So you'll notice that we do have points that kind of correspond to each other on either side of the parabola. So it is symmetrical. And when we talk about something being symmetrical, we have to have a line of symmetry. So the line of symmetry here is right in the middle. It actually goes right through this point right here. So we have a line of symmetry that goes right through, vertically, through my parabola, so that what's on the left is symmetrical to what's on the right. And this is called the axis of symmetry. So this piece right here is the axis of symmetry. And the axis of symmetry goes right through this point on my parabola, which here happens to be at the bottom, and this is called the vertex. So that is where the parabola kind of turns back on itself. So I've got two symmetrical sides to my parabola. I've got an axis of symmetry going down the middle. I've got my vertex where that parabola swings back onto itself. I can also think about which direction this parabola goes. So notice my vertex is on the bottom and it opens up. So we would say that this vertex is a minimum because it's the lowest point in my parabola. All of the other points in my parabola on my y-axis are going up above that. I do have a y-intercept here. So if we thought about where our y-intercept was, it does have a y-intercept of negative 4. So a parabola has a lot of characteristics to it that we can use to describe it and that we can use to help graph it.